Hello, welcome to Module 7. Before we start talking about the topics this week, I wanted to talk about the math project just for a quick moment. I've had a lot of questions in regards to the lesson plans that I'd like to clarify. You are only developing for the math project 5 lesson plans. And we'll talk about what the 5 lesson plans have to include once I get down to this bullet. You do not have to have a different plan for each of your 2 students. I would gear the lesson if possible to both of them, but if that's not a feasibility, then maybe making one geared more to one student, maybe geared more to the other student, or possibly gearing it down to the students who is the youngest might be more beneficial if that older student is still having difficulties with those same concepts. I hope that makes sense. If you need more clarification on that, please let me know. But no, I do not anticipate you having more than 5 lesson plans. You certainly may include more, but you're only going to be graded on 5 of them. So my expectations are that your lesson plan must be a minimum of 2 pages. I think any good lesson plan has to be in detail. Now I realize that lesson planning and regular teaching, we just don't have the time. I wish we did, but we just don't have the time to think about lesson plans the way we do for this. But as I said, keep in mind this would be as if a sub came in for a session of your math instruction so that they could follow and know exactly what you wanted them to do. So it's got to pass that stranger test. If it's shorter than 2 pages, it probably is not even including the main components. I mean, standards alone can take half of a page, so keep that in mind. I do have a 15-page maximum. If that's going to be a problem, please let me know. It shouldn't be because I think that's quite extensive. Standards, objectives, and assessment, they must align. I can't stress this enough. If they do not align, you are definitely not going to get, as I've mentioned before, a great deal of points on your lesson plans. It makes sense that they have to connect with one another. Your objectives really need to state how it's going to be measured. It's as clear as this. Standards and objectives are really easy because it's a topic. How you're actually assessing is what should be stated in your objective. So if that's a worksheet, if that's a test, if that's a rubric, if that's teacher observation, if it's a curriculum-based measurement, it doesn't matter to me how, but whatever you put in the assessment portion must be backed up by your objective. Also, if you add multiple assessment pieces, you should have multiple objectives listed, if that makes sense. Remember, I said only 5 lessons that you have to complete. You must have a procedural, declarative, conceptual, problem solving, and then of course another one, it could be free choice basically. You could even have your lesson plans be a combination of a few of these. It doesn't matter to me how you want to set this up. Remember, at the top of your lesson plan, you need to state which one is which. I will send it back to you and ask you to put that in if you do not label that for me. I want you to tell me which one you think is your procedural lesson plan or your conceptual lesson plan. You must be very explicit and clear in your direct instruction. Don't assume that I know what you're talking about. So if this is your declarative lesson plan, I want to see why this is a declarative lesson plan based off that explicit instruction. In addition, within those 5 lessons, you have to demonstrate at least one time co-instruction, technology, peer-mediated instruction, and teacher-constructed or adapted materials. You can have, of course, multiple of these in lesson plans, that's fine, but you need to make sure that you at least tap on one of these within one of those lessons. Keep in mind this is worth a 200 points, so this is a really, really big assignment. Here's an example of some of the objectives that I'm anticipating to see in your lesson plans, and I'm just basically throwing this out there and you could kind of see what the standard would be and then also how I'm measuring it. So let's take a look at this one. This isn't coming from an 8th grade standard. By the end of a math lesson, students will use square root and cube root symbols to represent solutions to equations of the form x2 equal p and x3 equal p, where p is a positive rational number, on a math worksheet with an accuracy of 80% or better. It's timely. It tells me by the end of the lesson. It tells me what they're expected to do. It's realistic for the student to be able to do. It tells me what the measurement is. It's going to be by 80% and how it's going to be measured, meaning the math worksheet. Okay, here's another one, 4th grade standard. Within a small group, students will identify role of a pattern to find missing numbers in sequence on 8 out of 10 trials as measured by teacher observation. High school transition one could be, in order for Tyler to budget his money independently, this week he will develop and maintain a weekly budget with 100% accuracy based on personal finance rubric. Your lesson plan could be the introduction to this week, and you could describe that the next component to build off is other things that they'll be doing that week, but you could just do one activity that would tap into this weekly budget, and it would be measurable because transition goals are a lot more and objectives that are more broader than our younger grade levels are. That's just an example that all of these examples are good ones that I will take. Okay, let's go ahead and start talking about this week's topic, which is problem solving. And of course, keep in mind that problem solving is that combination of conceptual, procedural, and declarative knowledge. This is kind of where it all rolls into one. Dr. Marjorie Montague states, many students, especially students with learning disabilities, have difficulty solving math word problems because they often cannot decide what to do to solve the problem. They look at the problem. Some students can even read the problem. They just don't even know how to get started, what the operations are, what they need to do. Most of our textbooks are really not helpful when it comes to teaching students the how to. We do a lot of, we'll pick out the key words. What is it asking you to do? Know what the vocabulary, what the terms are in math. That's helpful, but it still does not help them to structure how to solve problems. Typically, you'll see in most textbooks there's a 4-step formula. Read the problem, decide what to do, compute, check your answer. That's basically it. But understanding the problem is the core problem with a reading problem could really harm your students to understanding what they need to do. They need to decide what skills and strategies are needed in order to solve these problems, and this is a real issue for students with learning disabilities. They might not have the acquired background knowledge to be able to solve it independently, and therefore they require very explicit direct instruction, especially if the word problems are at grade level. So what's the framework? How do we kind of fix this? Well, keep the following questions in mind when you solve a word problem. When you are doing it, think about how you walk through a problem and explicitly share that with your students. You might answer questions like, how do good problem solvers solve math problems? Why is it so difficult to teach students to be a good math problem solver? What is the content of the math problem solving instruction? What are effective instructional procedures for teaching math problem solving? There's 2 stages to problem solving that I want you to keep in mind, and this has also been talked about within our Hudson and Miller text. It's that problem representation. According to research, one of the most powerful problem representation strategies is that visualization, making it very visual for our students. This typically develops for children between the ages of 8 and 11 for them to really be able to make those connections. So of course, students who have a deficit, keep that in mind. They might be older, but they might have deficit with their cognitive ability, or if they're younger than 8, hint, hint, it might be a little bit too much for them to figure that out in their head because it's a little too abstract. So that visualization is key. Execution is the other part. How do I actually start from here, go to there, and know what I'm doing and why? And also making sure that they're aware of what is the trash, because always we have so much information there, some of it's not even useful. I think it's really cute. I put in this cute commercial or cartoon just because I think it's hysterical. So it's for show and tell. As you can see, the boy put the head of a snowman in his freezer to take for show and tell. But the whole point of this is to make it that explicit. It is fine for us to show and demonstrate something and make it very simplistic. Sometimes less is more. So for example, if I had a word problem that I showed to a student who is having difficulty, the following problem, and this is a multiple step problem as you'll see. The art club is having a cookie sale. Each box cookies cost $2. The first day Jennifer sold 6 boxes, Marvin sold 7, and Cassandra sold 3. How much did the art club make the first day of cookie sales? If the group continues selling at the same rate, what will they make for an entire week? Include weekends. So that's a lot for students to kind of process. That's a lot of numbers, that's a lot of people. That's okay, do I need to care if they're in an art club? Does that even matter? What is going on? How many days are they selling these for? Etc. That's a lot. So a good way to kind of demonstrate this for our student could possibly look like this. So students who are having a difficulty, put in some picture cues that kind of helps them to be like, oh, okay, now I know what it's talking about. So the art club is having a cookie sale. Each box of cookies costs $2. The first day they sold and then demonstrated. Jennifer sold this many boxes, Marvin sold this many boxes, and Cassandra sold this many boxes. How much did they make that day? So then they could quickly look and add up these by just looking and adding, and then taking that number and multiplying by $2. Or they could even just list, this is 2, 2, 2, 2, and start counting by twos, 2, 4, 6, 8, 10, 12, etc. It might be helpful for your students to actually visually see it so they could actually touch it, they could understand it, they can see it, it makes sense, and then you could build upon that to the next part. Okay, well, now that we know this, how could we find out how much they would make each day, etc.? And then put that into a chart: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, so they could visually see it. To continue, the definition of problem solving is the process that involves applying previous knowledge, skills, and strategies to novel problems. As I mentioned, we might have students that don't have that previous knowledge, might not have the skills, and might not even have a strategy. So we've got to be very clear that we are providing our students with those tools before they even get there. Thus, that's where the conceptual, procedural, and declarative knowledge comes into place. Hint, hint. See how it all works together? Okay. Rationale. This increased emphasis on problem solving is reasoning per the NCTM standards, as you remember, and it's used extensively not only in school, but of course in everyday workplace, our living situation, and even leisurely activities. Here are some examples of that we can share with our students is where this fits into our workplace or daily living and even leisurely activities. We deal with word problems or just problem solving in general when determining our pay, figuring out overtime, handling money, with our daily living, just balancing our checkbook, measuring recipe quantities, telling time, with leisurely activities, just playing games, determining gas mileage, keeping score in sports, etc. You all use problem solving strategies to do all of those things. Students with learning disabilities in math have more difficulty with word problems, and here are some of those common barriers as to why that is. First, it's identifying the relevant information. What in the problem it really is important to know. Reading the problem can be the problem. Identifying appropriate operations. Does this mean I have to add? Does this mean I have to multiply? Does this mean I have to add and then multiply? Performing the computation in itself can be the hindrance to the problem. They might understand completely how to solve the problem, they just can't do the basic computation to figure it out. Translating words to equations. Okay, so if it tells me the sum or the product of or the quotient, that might be difficult for them to understand. Okay, what does that mean in relation to how I need to set up the problem? And then last but not least is performing high-level reasoning. Sometimes there's an extra amount of information that's asking for some analysis or some evaluation of something, and that's much more high-level thinking than just a basic simple computation might be. Word problem instruction. Well, it's really important, as we've stated before, to have a good understanding of those procedural strategies. Building our schema. Schema diagrams to represent word problems is huge. Two primary components are identifying the problem schema and write critical information about on the diagrams or labeling that for students. Even having the number family approach, knowing number families is really important with word problems because then you can see the associations between them. Once again, I'm going to say it again, always, always, always use that explicit teaching cycle with each and every single approach. Here are some just free worksheets that you can use to help your students with problem solving and to get them into a better place of knowing things, starting off with the basics. So here's some things here. There is a paid version of word problems that I just think is phenomenal. Sue O'Connell, I don't know if you've ever heard of her, but she is phenomenal. Sitting and listening to her presentations are amazing. And I know that some districts, I believe 7D, did adopt several of her different strategy approaches and even bought tons of resources for their classroom for their teachers. It's just amazing. So if you have time to go look, or even if you just want more information for yourself, I suggest checking out her website. I also have listed some things within Blackboard that you can check out as well underneath resources. This reminds me that before I forget this week, like I did last module, I wanted to also tell you what this week's password is for this week. Our password for this week is the word demonstration. So please send me the word demonstration. Okay, let's go on. Also this week you are going to be looking at typology, and so I also have a handout for this so you can take a look, but I just wanted to quickly go over this for you. There is addition and subtraction with change, combine, and compare. These are typology type of problems. And then in multiplication, there's restate, vary, the Cartesian product, and area. So become very familiar, look at those examples that you have on the handout, and it will help you to answer the quiz. If you have any questions, just let me know, but it's pretty straightforward as to know what kind of types of problems that we asked students to solve. Once again, please remember to work on your project this week for your graduate project as well as your math project. And of course, if you have any questions or any other thoughts that you need me to answer, feel free to contact me this week as well. Take care, and I hope you have a great week.